Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2022 IB chemistry examinations. This is an SL multiple choice question from paper 1A. Let's get started. It's worth 1 mark. Which combination of delta H1, delta H2 and delta H3 would give the enthalpy of the reaction? So we have some reaction right here, and they're asking the combination to give the enthalpy of this reaction. Okay, to solve this question we need to use Hess's law. More specifically, we need to apply algebra to Hess's law in order to solve the question. Now how does this work? Essentially, we need to rearrange each one of these equations in the right way and multiply it by the right number so that we can align it with this equation, our main equation, and cancel out what's necessary and be at the end left with only what is needed for this reaction. Now take a look. What are we going to do? Well, we need firstly CS2 at the reactant side. Where is CS2 among these three equations? 1, 2, 3. It's in the third equation, but CS2 is actually on the product side. So we need to switch it to the reactant side. So what do we need to do? Let's rewrite this equation with CS2 now on the reactant side. But what's going to happen now is that delta H3 now becomes a negative delta H3. When you flip the equation, the sign on the negative delta H changes. So in this case I flipped the equation to get CS2 on the reactants, and so positive became negative. Okay, the next thing we need to have CO2 on the product side. Which equation has CO2? Equation 1. Is it already on the product side? Yes, CO2 is already on the product side. So we can write equation 1 just as it is. So C plus O2 gives us CO2, and this has a delta H of 2. This is delta H, no, this is delta H1, sorry, and no sign change because I haven't changed anything. And finally, what is the last equation we have? Delta H2. We need SO2, as you can see here, on the product side. If you look at SO2, it's in delta H2, the second equation, and it's already on the product side. So again, I don't need to reverse the equation. I don't need to switch over the sides. But what I do need to do is multiply the whole equation by 2, because I need 2 SO2s, but I only have 1 SO2 in the second equation. So in this case, I'll rewrite this equation but multiply every single constant by 2. So it'll be 2 times S plus O2 gives me SO2. And now what happens to the delta H? The sign changes the same, delta H2, but it's actually 2 times that because I've multiplied everything by 2 times. So if I rewrite, I will just remove the brackets and expand this whole thing, right? If I multiply everything by 2, I get 2S, 2O2 and 2SO2. Now what do? Now we do some addition and subtraction. Let's get rid of anything that is opposite from each other. So a reactant side would cancel a product side. In this case, there's one C in the reactant side, one C in the product side of the second equation, so we can cancel these both out. If they're in the same side of the equation, we add them, and if they're in the opposite sides of the equations, then we delete them, like subtract them. CSO2 stays, then O2 and O2, these two add together, 2S and 2S cancel. So let's rewrite what we have. We have CS2 that stays, nothing cancels it. Then we add these two together plus 3O2, and that finally gives me, if I see CO2, nothing cancels that, CO2 plus 2SO2. Okay, now I am able to get the final answer just by using the proper changes. And so what do I know? What is delta H? Well, I know delta H is actually equal to negative delta H3 plus H1 plus 2H2. Which one is correct? We need a negative delta H, so it's not this nor that. It's got to be plus 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 plus. Okay, the answer is D. I hope you've understood everything. If you have any questions, please comment it below and I'll answer it as soon as possible. See you in the next video.